In this guide, we're going to walk through how we can iterate over a list of data in a React application, render it on the screen, and also how we can specifically work with TypeScript to help us guide our development. And this is going to help us to be able to get some insight into the data that we're working with, which allows us to make much more scalable and maintainable applications. So let's get started. I'm going to start off by simply walking through how we can iterate over a collection of data, and we're going to use the map function in order to do that. And then I'm going to go back in and I'm going to show you how we can integrate TypeScript types and interfaces in order to really kind of create the shape of our data and set the rules that our data is going to follow. So let's get started here. Right here I have a app component. This is our main app component, and then I have a data object, and inside a data object I have customer name, and then I have an array of objects called invoices. This is what we're wanting to iterate over. So what I'm wanting is here in the browser, I want it to print out the name and then the total for each one of these items. We're not going to worry about styling or anything like that. I'm simply going to show you how we can iterate over the data, because your own application is going to have its own set of styles, and so you can apply those however you need to. Okay, so right now we are passing to invoice list, our invoice data object. So that is everything we have here. Now moving up to our invoice list component, right now we're simply printing out the customer name, and that's Google, as you can see right here. That's our customer name. Now let's see how we can add in each one of our invoices. So I'm going to add a HR tag here, which is just going to give us a little bit of room. It's going to give us that line. And now let's see how we can iterate over the data. So I'm going to set up a div and wrap everything inside of it here. And then in curly brackets, I'm going to call invoices. Now when we passed our props of invoice data, we performed destructuring. So we're pulling this out. This is exactly the same as saying props dot invoices, or props dot invoice data dot invoices. But now I'm able to simply say invoices, which makes it a lot easier to read. So I'm going to say invoices dot, and you can see we're already getting some guidance here from TypeScript and from the text editor. Because invoices is an array, there are only so many functions that we can call on this array. So we're going to use map. So this is going to iterate over the collection of data, and then it's going to return an array. And so inside of that array, that's what each one of those elements, we're going to return some JSX. So in this case, I'm simply going to return a invoice. Now, the map function takes a function itself as a callback. That's the argument we pass in. And I'm going to use an implicit return type. So what the syntax is you call the data point. Now, there's nothing specific about this invoice name. This could be ASDF, it could be EL, it could be I, it could be anything you want. I'm going to call it invoice because every time we iterate over this invoices array, we're going to get access to an invoice. Now, inside of this function, I'm using an implicit return, which means that we are not going to use curly brackets, because if we use curly brackets, then inside of here I'd have to actually say the word return to describe what data we're passing in, and I don't want to do that. So let's add those parens back in, and inside of here I'm going to add a div, and then inside of the div, for right now, let's just grab that invoice name. So I'm going to use curly brackets once again, and then I'm going to say invoice dot name, and let's see what happens there. And that's all working. It's pretty small, so let me zoom in. So you can see this is giving us everything that we asked for. It's giving us that invoice name. Now if I were to open this up and look at the console though, you can see that we have a big red warning right here from React, and it says, warning, each child in a list should have a unique key prop. What does that mean? Well, this goes to kind of speak to how React works as a whole. React, when it is generating all of this code for us, remember React, the browsers don't understand React code. They don't understand TypeScript. They don't understand React as it's written. All of these elements like div, h1, these look like HTML tags, but they're not. This is JSX code. So these are technically JavaScript objects and functions that React uses to generate the HTML that we see right here. So don't worry if that's a little bit fuzzy if you're new to React. What that means is that React is letting us write our code in a way that looks familiar to us, that looks like HTML, but then it's doing a lot of work in the background and it is generating the code for us, but it's also doing a lot of other things. It is also doing what is called it has a diffing engine. And just in case you've never heard that, diffing. So it checks for the differences. So what it does is, part of the reason why React is so popular is because it was one of the first big JavaScript libraries or frameworks that was very performant. So years ago, so back when I started, and we had tools like just regular vanilla JavaScript, and then jQuery came along. Whenever you'd use jQuery to make a change on the page, it would go through and it would actually update, many times, the entire page's DOM, the document object model. That was very slow because you might only want to make one change, like toggle the visibility of a set of items on the page. Well, it would go through and it would have to touch all different types of parts of the page, and that could result in a very slow loading type page. React is much more intelligent. React uses its diffing engine to be able to pick and choose what gets updated on the page. So say that you had, and we can look at this page right here. We have our heading here, and then we have each one of these elements. And then imagine that we had a form, and we had a list of blog posts. We have all kinds of different things on the page. Then what exactly React does is, if we make a change to just one of these items, so say that we had a payment status, and we're going to actually add this in a little bit. We had a payment status for each one of these invoices, and we added a button to allow for making a change for that payment status. And then we wanted to maybe make a highlight change, like we added a check mark or something like that right next to it. With the way React works is it is intelligent enough to go inside of the code that we wrote, and it only goes and it updates that one element on the page. Instead of updating the entire page, it only updates that one element, which makes for a much faster loading and working application. And it's part of the reason React has gotten so popular. So that whole explanation is what is kind of what I wanted to talk about with that whole key prop issue. So you know what a prop is. A prop is like what we passed here with invoice data. This is one that we created and we defined. There is, any time that you're going to be working on iterating over a collection, there is a special prop that React provides called the key prop. Now, key equals, and you have to pass in something unique. So here I'm going to pass in invoice.id, hit save, and now we no longer have that big red warning. So what is this key doing? Well, remember what I said about the diffing engine. The way that the key works is it gives us the ability to tell React that all of these items on the page, so like this, an array, because remember, map returns an array. When we return that array, if we didn't provide a key prop, then what would happen is if we made a change to one of these items in the array, React wouldn't know how to go and how to run its diffing engine on the page, and it would have to do a lot more work than it really needed to. When we provide this unique key, and it has to always be unique, we couldn't pass in a duplicate key here, when we pass this in, we're giving React a unique reference point directly in the application that they can reach in and say, okay, now I have something to reference. I know that this has to be a unique item, and now I can go make a change to that item, or I can listen for changes, and I can run the diffing engine and do all of those kinds of things. So that is why we have to provide that key prop. So that is what that's for. So now we can also add in some other data here. So we have our invoice name inside of here. Let's wrap this up in a div. We'll add a few styles here just to make it so it's something it's a little bit easier to see. So I'm going to wrap up that, and then let's also do the invoice total. Hit save, and now you can see we have our invoice name and then the total, and we can use some embedded styles here. So inside of this parent div tag, I'm going to say I want to do a style, and we're going to do inline styles, and I'm going to do display, flex, and then let's say justify content is going to be space between. Hit save, and now that's going to split them up just like that. Now, this guide is all about, I want you to focus on this guide on iterating over items. If you've never seen how React works with styles, though, this can give you a little bit of a clue in on it. So we're able to provide a inline style prop. So this is a prop, just like our key prop, just like our invoice data. The only difference is invoice data is one we made up, and we can make up our own props for our own components. But div is also a type of a component. It's technically a function that we have, but div gives us the ability to pass in these types of props here. And inside of here, we're passing in an object, and that's why this syntax might look a little bit weird. Notice how we had to do two curly brackets? The reason for that is the first set of curly brackets is letting React know that we're going to run some JavaScript code inside of here, like with key. We have our key, and we have our key is invoice.id. With style, we have to pass in an object. So the double curly brackets, they're technically not, we're not passing in, you don't have to think of it as, oh, you use two curly brackets. No, we're passing in one curly bracket to define that this is JavaScript code, and then we're passing in the second set because this is an object. We could also extract this out. So say that we wanted to say, okay, this is going to be our item style container, and we could set this equal to this object. So I can cut that out entirely, and now I can paste item style container into that style prop, and you can see it's exactly the same thing. So I've had some students talk about how whenever they're working with inline styles in React in the beginning, it can be confusing because they don't understand the whole double curly bracket thing. It's not. It's simply this. We're creating a object that has styles inside of it, and they look a lot like CSS rules. They're not CSS. This is all JavaScript, but it does use a lot of the naming conventions, and then we're passing that object to a style prop here with div. So that's how we're iterating over, and that's how you can iterate over a collection of items in React. Now let's see how we can leverage TypeScript, because technically everything that we just did here, this is the same whether you're using vanilla JavaScript with React or if you're using TypeScript. So let's start to actually add in a little bit more TypeScript code to give us some guidance and to set some rules for how our data should work. So first and foremost, our data object here, this is something that if I saw this in an application, I would immediately know that there is a code smell here, meaning that this could lead to some buggy code implementation, because technically I could come to this list of invoices and I could do anything I want. So let's say that I want to adjust this and I want to add a payment status. So I can say payment status here, and let's say that it's paid. And I added that to this object. But then I didn't add it to these other ones. Well, I have nothing in the application telling me that I have a payment status, and if it's required or if it's optional, and what the payment status options are. So say, for example, what if I wanted to, inside of our function, our map function here, what if I wanted to add a different style if the payment status was paid versus not? How would I know what the rules are for what the data should look like? Well, that is where TypeScript comes in. So what I can do is I can actually come up here, and you can do this anywhere, but I'm going to bring it up here, and we're going to start breaking out our interfaces and our types, and we're going to define the rules that our data needs to follow. So I'm going to first take our invoices array here in our interface, and I'm going to cut this out entirely. So I'm going to cut that, and then I'm going to say that, you know what this is, let's say this is going to be a invoice type. So I can say type, invoice type, and then I'm going to set it equal to this object. Now I have a dedicated type for what my invoices need to look like. And now what I can do is in this invoices array call, here, I can simply say this is going to be invoices is going to be of invoice type, and that is going to be an array. So that, if you hit save, everything is still working. We have no errors here. So everything's compiling and it's working nicely. Now, what else can we do? Well, we can also add in the invoice data type. So right here we have this invoice data object. So what if I wanted to call this, and because kind of what I'm leading up to is I want to add a type that data has to follow. So I want to be able to do something like this. I want to say data is going to be of type invoice data type, and then that is going to say that there has to be a customer name, and then there has to be a list of invoices. So let's actually build this out. So I'm going to copy that name, come up here, and what does an invoice data type look like? Well, it's a type, so invoice data type, and then this is going to be equal to an object. And what does it look like? Well, it looks exactly like what we have here. So it's going to have a customer name, and then it's going to have those invoices. So I can just cut that out here. And then I can come up, get rid of this object call, and I can say that invoice data is of invoice data type, all right here. So this is all working nicely, and look how much easier this is to read and also to maintain. Now we have an error, which is a good thing. Come down here, you can see because we've defined invoice data type and said that this is what that data object needs to look like, now we have an error where I typed in payment status. So now we're getting to the point where I want it to be, where if one of these pieces of data doesn't follow the rules that we set in line, TypeScript tells us. This is exactly the reason why you use TypeScript. Remember, TypeScript does not get used or compiled in the browser. Browsers have no idea what to do if you gave it TypeScript code. TypeScript is for you as a developer. You use TypeScript because it helps you define the rules that your application needs to follow, and it helps you prevent bugs. One of the things I love about TypeScript is that I can come to an application that I haven't touched in months. It looks completely foreign. I barely even remember how the code is organized, anything like that. But because I use TypeScript, I'm able to look at the interfaces and those data types, and then that gives me some immediate transparency into how the data needs to be structured. So that's what we're doing right now. So let's take, for example, that we do want to add a payment status. So we do want to say, I want to mark something as paid or unpaid or pending or something like that. Well, now we can go up to our invoice type, and we can add this in. So I can now add a payment status, and this is going to be we're going to use unions here. So not only are we going to say there is a payment status, we can also say what statuses are available. So I could say here paid and then union type pending, something like that. Now what's going to happen is the only way payment status is valid is if it matches one of these two strings. And if you want to get really fancy, we can actually do something like this and say we create another type called the payment status type. Set this equal to paid and then union, so that one pipe pending, and now payment status is of payment status type. This gives you the ability, say in the future, you want to add another one. You want to add another one, like you want to say late or something like that, then you can, and it makes it very easy to manage, and you can also call this from anywhere else in your application. So now let's come down. We have some errors, but they're for different reasons. Now that first item is correct because it matches. Let's come down and let's add another one. So now we're going to do, for our second item, we're going to add a payment status. And as soon as I do payment status and then I start typing in the string, it already shows me what my three options are. So here I could say pending on this one, and then payment status, and set this equal to paid. So we're not using late, we're just doing paid, pending, and paid once again. I hit save, the prettier extension formats everything nicely for me, and now we have access to all of this. So say that we wanted to come in here and right after total, we want to add a little rule that shows if it's paid or unpaid. I can say invoice dot, and you can see each one of those items, ID, name, payment status, and total. We want to do payment status, hit save, and there we go. It's showing us, I'll zoom out a little bit, there we go, it's showing us each one of our items, it's showing the data points, and now we have a very clear view of what the data needs to look like. This gives you the ability to not only iterate over all of that data, but now you've defined the rules for what that data looks like. And that's really what using TypeScript is all about. And we're able to use both interfaces and types in order to make that happen.